The first module we have in grade 6, module 1, ratios and rates. Today we start with the first lesson we have in this module 1 about understanding ratios. The first lesson we have in this module is understand ratios. In this lesson, we need to understand the meaning of the lesson, the meaning of the ratio, and we need to know how can we create another ratio has the same relationship that we have in the original one. That means if we have a ratio, how can we compare this ratio or create another ratio has the same relationship for the original one. Let's see that in our examples. Then the first step, I need to know the meaning of the ratio. What is the meaning of the ratio? The ratio The ratio, as we see on page 4, is a comparison between two quantities in which for every A units of one quantity, there are B units of another quantity. The phrases for every and for each are used to define and describe the ratio. That means if we have two quantities and each one of them belong to one of the variables or phrases, we can write them as a ratio to compare that two numbers. For example, here we have ingredients for lemonade juice, and by these amounts we have here in these ingredients, we can make 10 cups of lemonade juice. Then if we have 2 cups of lemon juice, 1 cup of syrup, 7 cups of water, we can make 10 cups of lemon juice. Okay, we can see that and describe that by using the bar diagram. You can see here we have 10 cups of lemon juice. 2 of them lemonade juice, and 2 of them belong to the lemon juice. Then 2 of them lemon juice. And if we change the color here for simple syrup, we have 1 section, and we have 7 sections for water. If we have that ingredients, we can make 10 cups of lemonade. Okay, suppose we need to change this number, which is 10 cups of lemonade, to 20 cups to make 2 batches of lemonade, 20 cups of lemonade. How many cups of lemon juice will you need? You can understand that from this number that the amount of cups of lemonade will be changed from 10 to 20. That means 2 times as many as many of cups. Okay, that means the number will be changed from 10 to 20. That means we need to multiply what is the scaling factor to convert this number, which is 10, to 20. I need to change the number of batch or number of cups to be 20, 2 batches. That means the scaling factor here is 2 because it's double the number we have in the first ingredients. That means I have to go to each part of my ingredients and multiply it by the same number. That means the number of cups of lemon juice will be 4, and the number of cups of simple syrup will be 2, and the number of cups of water will be 14. If you add these numbers, you will get 20. Then I get the same relation between the ingredients by multiplying each value here by the scaling factor 2. This is the meaning of how to create the same relation by using the same scaling factor you used, because the number of sections here stay the same 10, but every part representing 2 cups. At the original one, representing 1 cup, but now 2 cups means 2 as many as the original one. And you can use the same idea. Look at this example here. We have here the mixture that you need to make one of the colors. Like here, we need to make a green color. To make a green color, we have two containers of blue paint and three containers of yellow paint. Then, to make this to make this ratio, you have to use the quantities you have from each color. Then this is the ratio, 2 to 3. How about if you have 5 containers of 5 containers of yellow paint? How about the number of containers of blue paint? If you can see here, in his opinion, Pedro added 2 more containers of each color. That means if you have 2 to 3, if you add 2 to each number, it will be 4 to 5. He, in his opinion, that if you add a number to one of the two quantities, you have to add the same number. But if you check here, uh, um, that then the ratio here is not the same ratio, because we have two ratios now. If you want to compare them to check that we have the same relation or not, the two ratios are 2 to 3 and 4 to 5. You can see here in his opinion that you are adding the same amount in each quantity, then you have the same ratio. But this is not correct, because the relation here is 2 to 3. For every 2 containers of blue paint, you have 3 containers of yellow paint. How about if the amount of blue containers now is multiplied by 2, doubled? It's now 4. You have to go to the other quantity and do the same thing to it. Then you need to add 1 more container of yellow paint to get the same relationship. That means if you want to compare this ratio to this ratio, yes, we have the same relationship. Then to maintain the same ratio, you have to check the relation to get the same ratio. But from that ratio to that ratio, the ratio was not maintained. Okay? Okay. Okay, the question now, and here we have the same idea on that question on page 5. The question now, we have different types of ratios, or we have the all of ratios are the same ratios? No, we have two types of ratios: part to whole ratio and part to part ratio. If you look at page 7, we have the first type of ratios, which is part to whole ratio. Here we have, okay, the small vase and the types of flowers it has. From carnations, we have 6 flowers. Sunflowers, we have 2 flowers. Tulips, we have 4 flowers. And the question is, if the large vase, this is the quantity in the small vase, But if he asked me, the large vase has a total of 36 flowers, how many are tulips? Then if I go back to the table, I don't have a row tells me the total number of flowers in the small vase. I have only the number of flowers from each type, but I don't have the total number of flowers I have in this vase, the small one. Then I need to add one more row to write the total number of flowers we have in the small vase. Then we need to add the 3 quantities we have in this table. 6 plus 2 plus 4 is 12. Then in the small vase we have 12 flowers. How about the large one? If we go back to the question here, we have 36. Then we have 3 times as many flowers in the large vase, because the 12 to be 36, we need to use the scaling factor. Yes, we need the scaling factor 3. We need to multiply this 12 by 3. 12 times 3 is 36. That means the scaling factor here is 3. If you need to ask me about one of these quantities in the large vase, I need just to use the same scaling factor, which is times 3. Then, if we go back here to the question, we can see that he wants to ask me about what? Yes, he's asking me about tulips. Then we have to go to that tulip and use the same scaling factor, which is multiplied by 3. Multiply the number of tulips by 3, then we have 12 flowers from tulip type. Then 12 flowers are tulips in the large vase. Then if we have 4 flowers of tulip in the small vase, we have 12 flowers of tulips in the large vase. How could you find that? By finding and discovering this amount 3, because each section of flowers in the small vase representing 3 in the large vase, means 3 times as many in the large vase. So we need to multiply by 3 each quantity we have here in the small vase. Okay, then if you can look at this ratio here, the relation here between part, okay, which is tulip, the number of tulips, to whole, which is the total number of flowers we have in the small vase. Then 4 to 12 is the first type of ratios we have, which is part tulips to whole 12 flowers, the total number of flowers we have in a small vase. And this is the ratio we have for the small vase. Okay. The large vase changed by multiplying both numbers by 3 to be 12 to 36. Okay. Then by multiplying both numbers by 3. Then here we have then we studied now the first type of ratios, which is part to whole. Second type of ratios, which is part to part ratio. In the part ratio, we will compare the quantities given in the table here. I don't need to go to the total number of quantities we have here in that column. Why? Because I will compare one of them to the other. Then I don't need the total here, because I compare part, which is 2 or 1 or 3, to another quantity we have here also in the same table. In bakery sells a fresh baked muffin, and here we have the quantity we have in the small box. In the small box, we have 2 blueberry and 1 cinnamon and 3 chocolate. He's asking me if in the large box the number of chocolate muffins changed to 9. Then it was here in the small box 3. Now we have 9. Then the total number is increased here by one of the scaling factor. Then if we have 3 and here we have 9 in the large box. He's asking me about what? He's asking me about the blueberry. How many blueberries we have. Then I need first to discover the scaling factor here I use to scale forward from 3 to 9 by multiplying by 3. So we have to go to the other quantity here, which is 2, and multiply by 3. Then it would be, yes, 6. Then you can see here the comparison here between what? Between part and part. The part here is the chocolate to the blueberry in the small box, and also the same relation between chocolate and blueberry in the large box, and the scaling factor that takes me from the small box to the large box scaling forward by multiplying by 3 times as many in the large box. Okay, now we studied the whole idea we have in this lesson. Then let's solve some practices from the review here we have in this lesson. Then the extra practice here guides me to the ideas, and we need to cover ideas that we have in this lesson. Then we need to cover them by using these practices. Look at the first question here. We have a relation between the number of chocolates and bubble gum. Okay, 5 chocolates and 7 pieces of bubble gum. Then the relation here, the ratio is 5 and 7, 5 to 7. Dan has 3 chocolates and 5 pieces of bubble gum in the candy jar. Then we have another ratio. Let's write the first ratio for Amy. 7 chocolates, 7 bubble gum. Then 5 to 7. Okay, and the second ratio for Dan is 3 chocolate to 5 bubble gum. Okay, what do you want to say? He's thinking that Emmy thinks that the ratio of chocolate to bubble gum in both candy jars is the same because they have two more pieces of bubble gum than chocolate. If you compare here the two ratios in his opinion, 5 to 7, we are adding 2 to the number of chocolates to get the number of bubble gum. The same thing here, 3 to 5 by adding 2 to 3. But if you look at the two ratios here, if you put them here out of the question, 5 to 7 and 3 to 5, you will find them are not equivalent. They are not maintained. This ratio wasn't maintained because if you look at here, 5 to 7, then if the amount change to be 3, I have to think about this number, the same relation. If you need to double this number, it will be 10. Double this number, it will be 14. If you want to decrease this number, divide them by 2. Then you can multiply or divide. But adding and subtracting doesn't make the same relationship. That means no, and the idea that she is thinking about is not right. They are not equivalent ratios. Okay, then I have to rewrite the two ratios out of the question here and think about them. Are they equivalent? Are they representing the same relationship? The second ratio was maintained. I can see no. Then the two ratios are not the same. Okay, the same idea we have in the second lesson here, that second question. Then I don't need to repeat the idea. I'll go directly to the third question, which is showing me the relation between three different colors, red, silver, and gold. A small package of craft beads contains the colors shown. Then this is belong to what? Yes, the small one, the small bucket. Okay, a large bucket has the same ratio, okay, of colors as the small package. If the large package has a total of 24, that means I have to go back to this number of colors and add one more row here representing what? Yes, representing the total number. Then I have to go here to write total and find the total of the three colors. The three colors here together, 2 plus 3 plus 3 equal to 8. Then the total is 8. And he's telling me that in the large bracket, the number will be changed from 8 to 24. Now you need to think about the scaling factor that you need to scale forward from 8 to 24. Which number you need to multiply 8 to get 24? Yes, you need to multiply by 3. So you have to go to each color and multiply by the scaling factor 3. But he's asking me about one of them. He's asking me about what? If you go back to the question, he's asking me about gold one. Then I have to go to the gold and multiply it by the same scaling factor by 3. So the gold will be changed from 3 to 9 to 9 colors. Then the ratio here, okay, we have uh, 9 9 golds, okay, and the small one was 3. By multiplying by 3, now we have 9. Then 9 gold beads. Then this question is showing me which ratio, what kind of ratio? Part to, yes, part to whole ratio. The second example, for Natty made gift bags for his party. He used the number of items shown. Natty later decided to add more items to the bag. He kept the same ratio of items. If the new large gift bag has 18 total items, total again, yes, total, then I need to go to that number, okay, or these amounts and check. Yes, I need to add one more row for the total. Then here I have to go to get the total, which is 4 plus 3 plus 2 equals, yes, 9. I have the total now. And he said to me that the total, which is 9, will be changed to be 18. Think about the number that you, or the scaling factor that you need here to multiply 9 to get 18. How, okay, yes, multiply by 2. He's asking me about what? He is asking me about stickers. How many stickers in the new contents of her bag by multiplying by, yes, by the same number, by 2. 3 multiplied by 2 equal 6. Then she has 6 stickers in the new bag. Okay, here we don't have a table in this question. The second kind of questions you can see in this lesson, there is no table, but you have the same idea. Okay, the ingredients, okay, or the contents, or anything you have, you will find here inside the question. Gina is making up bags of fruit for her soccer team. Each bag contains 2 strawberry. Then one of the best ways I like to solve the question to get the informations out of the question here to be clear for me. Okay, I have 2 strawberries. Then from the strawberry, I can just write ST. I have 2. 4 blueberries. Then you need just to write blue, BLU, and write beside it the quantity of blueberry, which is 4. And 3 raspberries. Then just write RAS and write the amount of raspberries, which is 3. If she used a total of 16 strawberries, then the amount that will be changed is the number of strawberries will be changed from 2 to 16. How many raspberries did she use? Then I have to go to the raspberry and ask myself, the total, the number of raspberries will be changed to what? Then I have to go back to the completed ratio given here, which is 2 and 16. I need to multiply 16 by what to be 2 by what to be 16? 2 times what? Yes, times 8. I need to go back to memorize the timetable to be easy for me to solve the questions in this lesson. Then he's asking me about raspberry. It's easy to multiply this number of raspberries by the same scaling factor 8 to get the amount. Then it will be 3 times 8. 3 times 8 is 24. Then 24 raspberries. Okay, you will find question number 6 has the same idea. Then I don't need to solve it. I go directly to the next page here. Then before we leave this question, I need to ask you a question here. What kind of ratios we have here? The same thing like the other 2 questions, or different type of ratios? Yes, it is the second type of ratios we have in this lesson, which is part to part. I'm comparing the number of strawberries to the number of raspberries. Both of them are parts. Then we are comparing part to part. In the previous 2 questions, we are comparing part to whole. Okay, you can see another type of questions here on this page about the multiple choice. We have one of the ratios and we have some statements here. One of them describes the same ratio and the others doesn't describe this ratio. Then you have to read it carefully to make sure that this is related to the ratio given in the question or not. The ratio of pickup trucks to SUVs at a car dealership is 2 to 9. Check all statements must be true based on that statement above. This is the statement. Then the comparison here between the pickup trucks and SUVs. 2 pickup trucks to 9 SUVs. For every 2 pickup trucks at the car dealership, there are 9 SUVs. If you check the order here, and the order here is very important to look at, you have to, Order of the quantities we have in the ratio here is mandatory. You have to check it. If you see here, first he is comparing pickup to SUVs, means 2 belong to pickup and 9 belong to SUVs. Then if you check here, 2 pickup, 9 SUVs. That means the first statement is true. For every 2 SUVs at the car dealership, then he changed here the quantities. That means this one is not right. There are exactly 2 pickup trucks and exactly 9 SUVs at the car dealership. He's telling me that this is the ratio and means that this is only the relation between the number of pickup trucks to the number of 9 SUVs. Maybe the number we have in the dealership is double these two numbers, means 4 to 18, or triple 6 to 27, and so on. That means these are not the exactly number of cars we have from every type. That means the third choice is not true because the ratio only is showing us the relation between the two quantities, not the exactly amount of each one of them. Okay, how about the last statement we have here? For every 9 pickup trucks, there are 2 SUVs. 9 pickup trucks, 9 SUVs, correct. None of the above is not true because we have 2 choices of these statements are true. Okay, finally, before we leave, we need to answer one more question from this idea that we have for understanding the ratio and how can we create a new ratio have the same relationship. This is the idea that we studied in this lesson today. There are 3 boys in a class of 11 students. The rest of students are girls. That means we have 3 boys and how many girls? If the total number of students is 11 and 3 of them are boys, how many girls we have? The rest of students. You need to subtract the number of boys from the total number of students. Then we have 8 girls. Okay, this is the ratio for the relation between the number of boys to the number of girls. But he's asking me about the ratio of girls to boys. Be careful, this is not the correct answer. Why? Because he started here with girls. Then it has to be 8 to 3. Okay, why, Mr. We wrote that here? We need just to know the number of boys and girls. And go back to the question to check which ratio he wants and write it on the same order because 3 to 8 is not equivalent to 8 to 3. They are different ratios. Then the true ratio he wants here in this question is 8 to 3, such as 8 is representing the number of girls and 3 representing the number of boys. Then when you want to write the ratio, you have to be careful about the order. You have to write the same order he wants in the question. If there are 2 choices, one of them is 8 to 3 and the other one 3 to 8, don't say, Master, we have two choices same, two same choices. No, they are different answers. And one of them is correct and the other one is not true. Why? Because the order in the ratios is mandatory. You have to be careful when you are reading the question to know which quantity you have to write first and which quantity you have to write second. Okay. Um, there are 3 green apples and 8 red apples in a basket. What is the ratio of red apples to all in the basket? Then the first step, I need to write the number of. Yes, I need to write the number of red apples. What is the number of red apples written in the question? Yes, it's 8. To what? I need to write it to the total number of apples we have in the basket. If you check here the basket, it has 3 green and 8 red. Then the total number of apples we have in this basket is 11. Then the ratio that we want in this question is 8 to 11. Thank you very much for joining to this session and see you later. Bye bye.